Hello, I am the Epic Gilgamesh on the Explain It To Me podcast. My co-host here is a biological Kalman filter.
Hello.
Yes. Okay, so the other day, I was trying to think of a joke to start off. I thought, okay, Trump jokes are funny, right? So I'm trying to think of a Trump joke in relation to, colonizing Mars. And I couldn't think of one. I managed to get somewhere. I managed to get Trump is orange. That's funny, right? And Mars is the red planet. There's a joke here somewhere. I don't know what it is, but so yeah, we're going to be discussing colonizing Mars today, and the difficulties and
by the way,
feasibility of it.
Gilgamesh, I just learned the other day that Gilgamesh may be the root of the word Moshe, which is the Hebrew word for Moses. And in fact, it turns out that a lot of the Moses mythology was plagiarized from the Epic of Gilgamesh. I don't know if you knew that or not.
I didn't know that, but it's entirely plausible.
It's a lot more plausible than Noah's flood. Let me tell you that.
That's the other thing. Epic of Gilgamesh has the Noah's flood in it.
Yeah.
It has Noah featured in it.
So not only are the books of Moses a complete fraud from beginning to end, they're also a plagiarism of work that was originally known to be fiction. Yeah. Someone forgot to tell these people that it was fiction in the first place.
Yeah, I mean, it's not a. From what I say, it's not a complete plagiarism. It's not a. I mean, I've read the epic itself, and it doesn't. There's no real one-to-one events.
No, they borrowed heavily from it and
rewrote
it. Yeah. So it's like they were all out of ideas, so they used ideas where they could find them. Anyway, but we're not talking about that. We're talking about things that are actually provable, demonstrable, and factual. And those are the interesting questions.
Okay, so let's get started with the episode.
Oh, okay. Here we go.
We're talking about the feasibility of Mars colonization, right?
Mars colonization, yeah. There was something in the news about this recently, too, where someone at NASA came out and said, well, one thing we can do to maybe make Mars habitable is put an artificial magnetic field out in front of the planet to protect it from the sun's radiation and particles. And this came out only within the last week or so. I saw this, and I was thinking, yeah, that's what I've been saying for years now. Nobody's ever going to live on Mars because it has no magnetic field, and you're going to get cooked. You can't have an atmosphere without a magnetic field. You can't have life without a magnetic field.
So can we make a magnetic field? Is that possible? And then is it feasible?
Can we make anything the size of a planet? I don't know. I would be very surprised if we could make anything that big that was effective enough.
Well, I mean, we're talking, feasibility here. So assume infinite money and all the resources we have.
Well, with an unending supply of energy, like maybe, solar energy on Mars is a fraction of what it is here. Maybe you could make a small dome that has Helmholtz coils around it that gives that small dome a small magnetic field. But would it be strong enough and large enough to deflect, incoming particles coming at almost the speed of light? I'm really kind of doubtful about the sort of engineering feasibility of this.
Yeah, you have anything on the science for that?
Well, we know the Earth's magnetic field is the thing that enables all life here to exist because it deflects high energy particles and radiation, and it keeps the atmosphere in without that field or buffer deflecting charged particles, it would just sort of sweep away the atmosphere and we wouldn't have it. And that may be what has happened to Mars because the molten core of Mars appears to have solidified and is no longer spinning and is no longer sort of converting some of that kinetic energy into a magnetic field. And the Earth's is still a molten core and is going to be for a while because of radioactive decay of things like uranium that's in the mantle of the Earth. So, but Mars, though, to get that entire thing going again on a planetary scale, it would seem ambitious, let's say.
So we can't just stick a giant electromagnetic at the North and South poles and...
Their plan was to make it more effective. They would put a smaller magnet or magnetized object way out in front of Mars to sort of give a deflection shield to the charged particles coming at it from the sun, and it would have to orbit the sun in about the same place as Mars while sort of maintaining its position. Now, orbital mechanics would say that no, you're not going to be able to do that. It's going to get out of sync and it won't hold that position. But if you have plenty of energy and plenty of money to throw at it, maybe you could set up a constellation of satellites that always, of which there's always sort of one in between you and the sun if you're on Mars, so always eclipsing the sun from the point of view of Mars and deflecting charged particles out of the way. And then maybe, if that is done for thousands of years, you could rebuild the atmosphere on Mars by regenerating oxygen and nitrogen out of some of the minerals on Mars. And that's been the subject of some science fiction movies too in the past. But we're talking.
So we can't just shuttle a whole bunch of air from Earth and just dump it on Mars and.
Yeah, that was the subject of a movie too. I think didn't Spaceballs do that?
Yeah. Yeah.
Right. Yeah, it would be an enormous amount of material having to be transferred. You have to use as much of the stuff that's already there as possible. Now, maybe you could make a few small huts and domes or something that you could maybe live inside of, but those domes would have to confer on you all the protection from the radiation of space and whatnot, and the atmosphere you'd need. There would be no sort of living on the surface of Mars, free under the sky, farming potatoes and whatnot.
So just how bad is this radiation?
Oh, it'll kill you within hours, if not days.
Hours, if not days.
Yeah.
So how does this compare to radiation we might encounter on Earth from natural or
Fortunately,
man-made sources?
Fortunately, you don't encounter this kind of radiation on Earth unless you go out of the magnetosphere, not just out of the atmosphere, out of the magnetosphere. And I think the Apollo astronauts may have ventured out of the magnetosphere on the surface of the moon for a short time. I think a large part of the magnetosphere even encompasses the moon. That's how big it is. It's huge. Of course, it's a planetary scale magnet going on in the core of the Earth. And I don't really think that we can engineer something of that size if it doesn't occur naturally. But it would be kind of like getting inside the beam pipe of CERN and sunbathing inside it. Of course, it's not equivalent because the beam in CERN is a pencil diameter sort of beam that would just bore a hole in you straight away.
Okay, so you think that it could be feasible to make a dome that has magnetic radiation shielding?
Yeah, unlimited resources, you could probably do it. Yeah, eventually. But while you're up there, you're going to be depending on sort of metallic vessels and little domes or housing or modules or something to protect you while you're up there building the stuff. Unless we send robots. We can send robots to build all the stuff. We're not far away from being able to do that quite feasibly.
Okay, so given radiation shielding, is that enough to justify, maybe not justify, but allow Mars colonization?
Wow, I think it's one piece of the puzzle. One.
So it's not this. Is it the largest obstacle? Or?
I think it's the main obstacle. For me, it's the deal breaker. Colonize Mars? No magnetic field? Nope, deal's off. That would be the first thing that would have to be resolved. And then the other things that would have to be resolved are numerous. And for me, the chief of them is why? What is there on Mars that we need that we don't have here? And
we need space. we need space to have people live there.
We need elbow room. Well, maybe we could just maybe we need contraception more than that. So for me, the argument always shifts away from space exploration and technology to one of just sort of managing our home planet and managing ourselves. Are we not willing to do that as a species yet, well, we're just going to ruin another planet until we have done that. It's kind of like you run from your problems. You can run to another planet, but you bring your problems with you. Why not just deal with your problems?
Right. But let's say, there's some sort of organization that, considers contraceptives and contraband to be immoral, and they have a majority population in some of the leading countries.
Well, they can go.
Let's say that's the situation, and so we can't get rid of this problem because there's crazy people in charge.
Well, they could go to Mars. I'm happy with that.
So, okay. Right. They don't even need the magnetic shielding.
No, I don't. I'm fine with that.
Joke. Yeah. Okay, so that's the situation we're in, essentially. I don't see that changing anytime soon. We're not going to see any wide-scale population control incentives.
No, we're not going to. And the thing that
there's too many issues, and the only way it could ever really get through it is in a, highly authoritarian government.
Yeah.
That doesn't take into account the will of the people.
Yeah, not a good solution either way.
Which I mean, I've been not opposed to that kind of government for these kinds of reasons before, but at the end of the day, it's not really the best option either.
No, I mean, lots of people fantasize about a benevolent monarchy, a benevolent dictator, but, when does that ever happen? It doesn't. Power corrupts, and if someone has absolute power, then there's lots of people whose rights aren't protected and whose opinions aren't being taken into account. But so we're never going to get rid of the people who are opposed to contraception and population control. But offering them an easy out, I think, is counterproductive. Saying that, well, if we do it, what was I saying?
I think we were going off on a tangent about benevolent dictators.
Yeah, okay. Well, I mean,
essentially, there's ideas about how to deal with that, but we're talking about Mars colonization, so...
Yeah, and so coming back to Mars colonization, giving people the easy out or the easy option of saying, well, if we stuff up this planet, we'll just go to another one, I think maybe encourages bad decision-making a little too much. I think we have to kind of be forced into taking hard decisions because of the reality of the lack of anywhere else to go. Right.
So, but would Mars work as a population dump?
Well, there's technological barriers, there's scientific barriers. In principle, they could all be overcome with unlimited resources, but the long-term solution is that it too will become overpopulated because human consciousness will not have progressed beyond the same consciousness that overpopulated this planet. So the long-term solution is no, it's not an answer. The short-term answer is that it's also not an answer because it would take enormous resources away from doing lots of other things, and through impoverishing the rest of the planet. Maybe that's how population control would happen, but it would happen at the expense of a lot of suffering. So short-term and long-term, for different reasons, I would say no, Mars isn't the answer.
Okay, so how about this one? Mars as a luxury resort.
Okay, sure, I'm up with that.
Or as a escape for the world elite.
Yeah.
The secret cabal.
Yeah, as a playground, as an adventure, exploration, extreme holiday kind of thing. There's still places on Mars where humans can go that no humans have ever gone before, or even robots. And for people that really crave that sort of exploration spirit, fine, yeah, go for it, do it. I think in order to enable it, we're going to have a lot of robotic technology prepare the way, and we have to do it in a way that sort of balances the resources to do it. I mean, if that's somebody's choice to do it and they have the resources to do it, nobody else has the right to say what they can and can't use their resources for. So sure, and in the long run, maybe the technological and scientific obstacles can be overcome. They can figure out a way to not die from radiation, figure out a way to not kill each other from the psychological burden of being on a 2-year round-trip confined space mission. And if they can solve those problems, then yeah, do it.
So let's move back to the practicalities of it. So one of the things you just brought is the distance, the sheer amount of time it takes to get there.
Yeah.
Is that something that can be cut down effectively?
No, not without just planetary size amounts of energy thrown at it, and we don't have that much energy to spare. And collecting that much renewable energy from the sun would just take so many resources away from the rest of the planet. Basically, the way you get from one planet to another is through something called a Holman transfer orbit. You draw an orbit around the sun that happens to intersect the Earth's orbit and Mars' orbit at exactly the times and points at which Mars is at that point in the orbit and Earth is at its point in its orbit. And so mathematically you solve the equation for the two orbits for an orbit that intersects the two at the right time, and you draw a line between them, and then that's the line you have to follow. So essentially you're orbiting the sun in an elliptical orbit that intersects the Earth's and Mars' orbits.
So wouldn't that just take 1 year then?
It takes about a half a year if you get it right. But there's also sort of staging time. You have to get out of the Earth's atmosphere. You have to orbit around a bit, get yourself in position at the right date in the year, and then fling yourself out onto this Holman transfer orbit, which means picking up a serious amount of kinetic energy and then use that kinetic energy to orbit the sun for half a year or so, and then get to within the vicinity of Mars, and then get ready to get rid of some of that kinetic energy, slow yourself down so that you don't just whiz past Mars and keep going around the sun. And so that takes time too. So we can look this up, but I think that the NASA Mars missions take somewhere between 6 months and 12 months just to get to Mars, and then coming back would be the exact same thing in reverse. So it would be somewhere between at least a year at top speed efficiency with no time on the planet, and probably more like 2 years, including a couple of months on the planet itself.
So these are pretty big undertakings.
Yeah, this wouldn't be a weekend away. There. Yeah, this would be a lifetime, life-changing sort of mission.
Yeah, and so and this would be for like a small craft.
Yeah,
right?
Yeah. This would be
does this change for a larger, cargo-bearing craft or personnel-bearing craft?
It takes longer the heavier it is. If you've got a mission of, say, 3 to 6 people, it would be along that scale. What we don't know is that will people who spend 2 whole years like that, will they be permanently psychologically damaged, or will they function again in society? I mean, I guess we can compare that to people who've been in solitary confinement and prisoners of war for that long, and we do find effects, but will they be able to refrain from murdering each other by the time they get there or before they get back?
That could be part of the fun.
Yeah, part of the experiment, part of the scientific learning. But, then we have the ethics.
Experience Mars and experience the thrill of not knowing if your bunkmate will try and stab you to death.
Yeah, I mean, it might not be ethical to use humans in such an experiment like that, but if they volunteer, we can hardly deny them. If we have the technology and resources to do it. But yeah, it would be, it would certainly be a major feat of human accomplishment and a triumph of science and technology in engineering. But it is very, very ambitious. Okay. Though, is it on par with the ambition of going to the moon with 1960s technology? I think that is just mind-blowing. I think it's probably on par with attempting to do that.
So you think it's feasible with the right determination?
Yeah.
Because from what I understand, that's what really drove that. It was, we're going to get to the moon, God damn it, and so they did that.
Even if it kills us. Yeah, and they took risks. They took terrifying risks that we would not take today. And they were using technology that was very cutting edge, but very crude by our standards. And it is just mind-blowing. It is phenomenal that they were actually able to pull it off, which they did, for sure, by the way. There's plenty of proof that they did it. And it would be on par with that, I think, being able to go to... We know how to get to the Mars and back with light spacecraft. We know how to keep a human alive for that long. It's putting all the pieces together and dealing with some of the things like the long-term radiation exposure, long-term confinement, long-term microgravity or zero gravity, what that does to the body. But... we can put all of those pieces together, and we could do it if there was basically unlimited resources. But what could we learn doing that we couldn't learn by sending robots?
Right.
Until it becomes routine, then it becomes like we said before, tourism.
And it could raise funds for additional missions. Find a billionaire who wants to go visit Mars and say, okay, fund us for everything else.
Yeah, sure. And doing that is going to develop the technology and learn a lot about the processes of how to do it. So like any industry, it's going to be a work in progress and learn as we go. Now, I had heard that Stephen Hawking is going to be put on one of the space flights in a year or so.
Really?
Who are those guys that are offering space flights?
SpaceX,
Virgin Galactic, or something like that. So Stephen Hawking is going to be on one of them, which is pretty cool.
Okay, so that was our first episode on the Explain It To Me podcast, in which we discussed the colonization of Mars.
Can we or should we go to Mars?
The answer was
no.
we probably shouldn't. We probably could.
Well, I personally have a lot of better things to do.
There's better things to do than go to Mars.
Let the robots do it for a while.
You've just been listening to the first episode of the Explain It To Me podcast, where we discuss the feasibility of colonizing Mars. I've been the Epic Gilgamesh, and my co-host has been a biological Kelman Filter. Join us next time as we go further out into the final frontier to discuss the possibilities and impossibilities of interstellar travel. If you have something you would like to explain to us, you can email us at explainittous@gmail.com or over on Twitter at explainittous. Until next time, keep thinking.